I think time to start this session. Uh, yeah, I'm thank to Dr. Aksam who accepted the invitation. To deliver the industrial lecture at VIT. And I thank to our school dean and HOD and school dean Dr. Sandan Mandal for accepting the invited guest lecture and our VC sir Kota Reddy and to the management. And today the guest is MD Aksam. Aksam is here to deliver the talk on numerical methods to artificial intelligence via machine learning. And a small intro about the Aksam. So Dr. Aksam got his BSc degree from Tiruvallur University and MSc from Pondicherry University and PhD from VIT Vellore Institute. And later he joined at Jetta Lab in Bangalore. And then he moved to the Secure in 2000. I think from there he's working there as a senior data scientist. His expert is cyber security work, and then the supervised and unsupervised cluster algorithms, deep neural network and regression analysis, and then data cleaning, web crawling, etc. And today is here to deliver the lecture on numerical methods to artificial intelligence via machine learning. So I invite you, Dr. Aksam, to please go ahead the lecture. Thank you very much. Yeah, please go ahead, Aksam.
Yeah, thank you for my introduction. So can you hear my voice and can you confirm, can you see
yes.
my presentation as well?
Yes, Aksam, everything is perfectly fine. I request you, there are BSc students, might be the BTech students also. You please go in a slow pace and make sure. Yeah. So not in a hurry. Just, yeah.
Yeah. First of all, I like to thank Ramakrishna Reddy, Dr. Ramakrishna Reddy sir, and as well as VIT AP management to give me an opportunity to have a talk for your students. It will be an interesting way in which we will have a presentation right now. Just going to that. By telling about myself, some of the introduction which even Dr. Ramakrishna Reddy sir also told about myself. Telling about my name, Muhammad Aksam BK, and a senior data scientist from Securin. Securin is a cybersecurity company which has been working on cybersecurity world, where exactly vulnerability, exploits, and weakness related to cybersecurity world had been the core idea to work on, and as well as they have been working on some of the data analysis technique as well as machine learning and artificial intelligence technique to come up with the scoring of vulnerability and exploits. So in and around of it. So this was just an introduction about my organization and my team. I have been working with 5-member team who is related to data science world. So getting into the title of the talk today, numerical methods to artificial intelligence via machine learning. So I was told to have some basic introduction about numerical methods, in the sense that you are having the course as a student right there, and slowly just slowly getting into the introduction of what is machine learning and artificial intelligence, how exactly numerical methods have been helping the hand of machine learning to come up with the solution to the problems, and how exactly we can implement it into the exact real life problems, and how to solve it and how to model it. So I am from mathematical background. So I will be just walking you through the mathematical perspective, because it will give you the crust of how exactly those mathematical modeling and the solution finding approaches are modeled. And mostly as data science and data scientists right over there are using those mathematical problems as black box, and they are interpreting the results from there. But for sure it is helping uh, those solutions are helping them to solve the business problems, finance problems, and even real world day-to-day life problems, and we are coming across with. So let's just start with the first introduction to numerical methods. You know that what exactly is the numerical methods? Instead of coming up with the accurate solutions, or in mathematically we used to call analytical solutions, there exists a method, numerical method, which will give you an approximate solution to the problems. Now the questions are, why we exactly needs an approximate solutions, why can't we have an accurate solutions? And this exact idea even some of the mathematicians have raised. Even myself, I used to be questioning that if mathematics can give an accurate solutions, why it needs an approximate solution to the problems. Then after having a lot of problem solving techniques, and after learning those problems for a while right now, I also validate, like there are certain problems for which even right now there is not having an accurate or analytical solutions to it. At those point of time, we need these approximate solutions. And how much these approximate solutions are used nowadays, it's also the questions. In further slide I will be stressing right over there. But uh, regarding the mathematical problems are solved by using an arithmetic operations of numbers. This is just like a computer science students used to say, like divide and rule based approaches. So you divide your problems, you divide your equations, in which if a physical phenomena is mathematically modeled, into several pieces and accumulate it, and that will be giving the accurate solution of it. So what are all the things which you can use to solve these problems? I still remember in numerical technique papers in my school days, I have been using calculators, and in those days or even now scientific calculators are used to calculate it, to have a numerical values to be fed and to calculate those things. Not only that, in very advanced way there exist computational techniques and high level supercomputers right now available to solve real world problems. For instance, I have seen in my previous experience, like we used to write Fortran code or even Python code to solve partial differential equations problem, uh, and it will run almost 1 day or 2 day. For instance, like a droplet problems, or even like biological flow problems, fluid mechanics problems. So those are all you can write a code and computer can solve a solution, accurate solution for you. So so what is the example of getting to understand this numerical method? For instance, if we have an integral a to b f of x dx, we will have uh, the x-axis and y-axis. Y-axis is f of x dependent on x, and assume that we are dividing it to 5 different intervals to come up with specific area under the curve. For a b c d e, 5 different parts we cut into pieces, and this is nothing but an example of extended trapezoidal formula. So we just cut into several pieces of n intervals, and then accurately solve or area under curve of it, and then add it. So this will give an approximate solutions. For sure there exists some of the areas right here, uh, because the curve is very smooth, and the approximated curve is not much smooth, you can see. So there may exist some error, or it may not be an accurate solution for it. That's what we called an approximate solution for it. Okay, moving further, what are the different methods to solve these problems of numerical methods? There are iterative problems. In the sense, you go on taking a initial problem, initial value, you give it to it, and your problem will approximate it continuously, and it will iterate continuously to reach the exact solutions. And still there exists some of the problems which doesn't converge up to, it doesn't converge to exact solution. So there exists some of the problem which goes up to infinity. So still we can able to solve limited number of problems, which we called in mathematics in well posed problems, or which cannot be solved is in ill posed problems. For some of the researchers in biology and even fluid mechanics, they used to call some of the problems as ill posed problems. So uh, this is just a solution method. Following that, okay, if you are finding an approximate solution to the problem, then how much error we can tolerate? Assume that there exists a huge gap between the exact solution and your errors. No, we cannot accept those so vast error. So we used to calculate those errors separately, and which is acceptable. We call it, we gave some criteria to accept those errors. For instance, like in probability, people used to call how much confident you are, what is the confident interval of your probability, or how confident you are in your problem. At least it should be 95% your confidence. So for instance, like the exact example is mean obsolete error, uh, the exact solution value versus your what you got. If you find the difference of them and sum it up, you will get mean absolute error. So this is the method where you will be calculating the errors of it. So once your errors are very less, or whether your errors are getting very low, then you should be very confident that your results are very good, and it is almost accurate. Cannot be an exact accurate solution, but sometimes it attains as well. Okay, uh, what are all the types of numerical methods we come across, and what are all those commonly uh, actually some of the mathematicians are come up with those methods, so it was with their name behind them. For instance, bisection method, regular falsi method, secant method, Newton's method, fixed point approximation method. These are all the methods of finding the root of a equation. So a equation will be having based on variable x, and you will be finding the values of x. So there are exact methods people have come up with, and it is giving exact solutions to those problems. So the next different numerical methods are method of solving the system of linear algebraic equation, interpolation and regression. This is nothing but curve fitting or nonlinear curve based interpolation, which you used to come across with several numerical analysis and numerical methods problem. And numerical differentiation and integration, if the order of differentiation or integrations are getting higher, or even you can see some of the partial differential equations and integral equations. Right now it has been developed in mathematics, integral differential equations. So stochastic differential equations are, it is based on stochastic formula, but still there are several methods which are all under this numerical methods, and solving the solutions of the differential equation. And sometimes you will get a matrix problem. You will make n cross n matrix, and then you find the values for all those n cross n matrix. So it is interesting to solve those problems again by using numerical methods. Uh, Solution of boundary value problems, most of the fluid mechanics problems are also based on these things. Moving ahead, numerical method versus numerical analysis. So numerical method I have been talking about, it is a approximate solution to the mathematical problem. But numerical analysis is the application of appropriate numerical method to a physical problem. Assume that in your day-to-day life you come across with different problems, you convert into a equation and you try to solve by using numerical method. That is called numerical analysis. So it is a systematic manner you should come up with a solution and make interpretation what exactly or what is the solution, and you will give a solution which is exact, really helpful to the problem solvers, or to the business or to the day-to-day life for a people to come up with a solution. So you have to come up with algorithm programs, or even by using computers you solve the problem. So one of the example which I got from the uh, one of the problem which is based on football player. A football player takes a free kick to try to score a goal. So he has to kick a goal. So as okay, it should go above it. His plan is to make the ball go over the goalkeeper head, assuming that this kick gives the ball an initial velocity 25 miles per second. Find the angle theta naught for which the player will score the goal. You know that the ball goes above the height of the tent of the goalkeeper, but it should slant back, it should reach inside the goal. As I used to see these football players used to kick in different directions at different angles. Sometimes even it is interesting problem to understand. Some of the commentators even say like Messi used to hit in different directions, in different angles and all. So this is again, you can see that use any numerical method you have learned to solve this problem. So this is the problem which this is nothing but an example of numerical analysis, where you will use numerical method to solve the problem. What is the angle a footballer or free kick hitter should take to reach the ball to the inside the goal, but it should not be much away from it. So these are all the solutions. If you find a solutions theta naught, then that's the thing. It will give you you can just have an idea to have a proper hitting of this goal. So with this example, we can move ahead. Okay, assume that to solving this problem in your notebooks, and you see several times we will be having several iterations of the problem, and you start solving the problems solution from iteratively to get the solution. But instead of that, if you have your skills built to write those problems, to convert the equation of the problems into a computational programs, and you try to solve by using initial values, then a huge you can save your huge time, and the computer is very fast to come up with its problems. I remember some of this mathematical modeling of cardiovascular system while I was doing research in IISc lab, where we used to convert the partial differential equations into the with initial value problems into the programming code and fed it to the computer. So it works all over a day for a computer of 30 GB RAM to come up with the solutions, 24 hours to come up with the solutions, which if you do manually, I don't know manually how much time it will take. So it is a interdisciplinary problem where a computer uh, programming and software oriented skills you should acquire or you should learn to convert your mathematical problem to it, and then you solve your problems and you give an initial solutions, and always see that it should not be an infinite loop. Instead it should get a finite number of or sometimes you give a finite number of iterations to attain your problem. So you should have all those interdisciplinary skills, and in computers you have to also have a understanding of an algorithm to solve those problems. But there are several books which can help you out to have to figure out how to how to how to make that problem a computer understandable, and how to feed it and how to get the solutions. Moving ahead, what are all the computational solutions and how several mathematicians come up with this? To facilitate computational solutions, Newton and Leibniz invented integral differential calculus. Various accurate mathematical models were developed, but they couldn't be solved explicitly. So the problem which are all devised by or mathematically modeled equations devised by Newtons and Leibniz are not solvable by using analytical solution. To simplify, several numerical methods were created by Isaac Newton. Following his work on root finding and interpolation and curve fitting, many other legendary mathematicians like Euler, Lagrange, and Gauss contributed to the field of numerical analysis. For instance, you can see there are there are certain mathematical problems which several mathematicians come across are very complicated, very uh, difficult to solve by using mm, by using analytical problems. For instance, it's a mathematical modeling of cardiovascular system where exactly the heart wall is elastic. So the equation is elastodifferential equations. By using arbitrary Lagrangian Eulerian method, people used to solve, and and those are all very complicated, and lot of parameters and lot of physical phenomena had been captured in that. So so people come up with different numerical methods to solve those problems, or different state of fixed state, or different state people come up with, or different boundary value problems people formulated to come up with the solution. But still I'm not with this mathematician. There are several problems still ill posed, or which cannot be solvable even with using computers, because it cannot be formulated to the computer so that it can solve. There are certain problems right over there, or you can even Google search to find those equations and problems, and you used to be hearing that several mathematicians have solved those problems, and they used to get highest highest accolade, or highest award if they come up with, or they come up with solving those problems or solving those conjectures. It is equivalent to Nobel Prize in mathematics and Abel prizes. People used to get even now for solving those very difficult problems. I always motivate the students to observe those problems, and if you come up with up to the research level, you can able to solve those problems. I used to motivate some of the students to have this will to solve a challenging, grand challenging problems, which is announced by several world's university, and it is open to the people. Anyone who solves the problem will get a several awards to those problems. Moving further, there are different methods for solving this numerical analysis problem. For instance, a direct method, or exact solution will you will be attaining by getting finite number of steps. For instance, in 8 steps you will get a solutions, or in 10 steps you will get a solutions. Mm, One of the example of it is Gauss elimination method, is used to find the root of the linear simultaneous equations by using finite number of steps, which is given right here. But what about an iterative problems, which sometimes even doesn't converge to any exact solutions? So you will be giving not expected to finish off in a certain number of steps. So some of the examples of them are initial guess and convergence to the exact solution, Gauss-Jacobi, Gauss-Seidel, are iterative method used to solve system of equations with larger number of unknowns. And you know that it is not only the problem of the equations. If there is large number of unknowns, for instance, if ax equal to b, only x is a single variable for which you want to find a value. If it is x comma y comma z, so there are three different unknowns for which you want to find a value inside the equations or a set of equations. So several problems are very complicated to be modeled, that to be in a three-dimensional problems, in if it is in three different dimensions, x, y, z, and what are all the values of x, y, z, and if it is increasing, the number of unknowns are increasing, again it is a very problematic to solve those problems. Moving ahead, field of numerical analysis is divided into various disciplines. Okay, what exactly is the discipline? For instance, different kind of problems are there, like interpolation, extrapolation, which you come across right now in numerical methods. Interpolation is to construct the data point within the range of it. For instance, there are several points, you draw a regression line and you want to find at this point what is the x and what is the y, x comma y point. So it is among the points, and internally you find the element, or you find the values of it. Once it is an extrapolation outside of those points, outside of those lower and upper pole, still roughly evaluating the value of the problem outside the range might not be much higher accurate, but still people are finding those by using extrapolation methods. So this is the two different methods, and this can also be called as a curve fitting, or even you can call it interpolation methods. Moving ahead, regression is the statistical process where the relation between the dependent and independent values. For instance, you try to draw a curve or a line. For instance, a linear line is nothing but y is equal to a0 plus a1x. If it is a parabola, for sure it will be in y is equal to 4ax. So y square is nothing but a non-linear equation. You try to fit an equation by multiplying y twice. That's what it attains, y square. And the curve is also, it is bending. So you have to understand the problem or the equations, whether it is a linear equations. Linear equations you can easily solve by using normal methods. But once the equations are getting non-linear, so it will be very difficult to solve those problems. So moving much more ahead, solving differential and integral equations. Most mathematical problems are based on solution obtained by partial differential equation, ordinary differential equations, or integral equations. Some popular techniques are Monte Carlo integrations and Newton's cotes formula, or numerical methods which can solve these problems. And where to use which formula or which exact method will help us out, you should be understanding the problem well to get the solution of those problems. What is the exact method we have to use for it to come across? So, so moving for the application of it, okay, you know what is numerical method, you know the to solve it, how to solve it, what are all the applications of it, where are all these kind of problems or this kind of numerical analysis people used to do, and what is the impact to the real world problem, what is the impact to the general people or real laymen. So the car safety enhancement. So as you know that there are a lot of sensors from which a data is obtained, and a car maker around the globe, or even right now you see several car makers like Tesla and all, they are trying their best to come up with manless driving or autopilot mode. Even Volkswagen is trying to implement it. So what they exactly do, they do uh, numerical analysis, they do uh, crash testing, they do what is an impact of a car hitting to other car, or pedestrian uh, uh, site. If it hits, how much problem it will cause, or whether it will be causing the death, and where are all the weakness of the car. It should be set it right, so as this car should be much more safety for the people. So the algorithm involved are partial differential equations fed into advanced computers to unravel optimal results. Not only that, these initial signals are random signals, or the signals which they are getting through the sensors are fed as an input value for those partial differential equations to find out the the stress which it is getting on those car, and where exactly you should have a heavy metal to safeguard the people inside it. Moving ahead, in biological problems, uh, there are several problems. For instance, like uh, progression of tumor cells. You know that if a cell is dividing continuously and it attains a cell that it is having a natural growth, and every body, every human body has several cells, and it should grow so as to support our living. And once we are getting older, a lot of cells are getting death. But if it is going an uncontrolled proliferation, uncontrolled growth, and then that's the cause of cancer. So there exist several parameters. Based on that, people or scientists are studying the problem of this cancer in biology. For instance, like cost effective statistical and probabilitical model, where, as you know, that you cannot operate, and every time you cannot do a physical experiment on the patients. So it will be very cost effective if you come up with the equation out of the problem and try to solve it by using the computers. And there are several computational labs nowadays. Computational biological labs are available to help those, to support those research. uh, and several parameters for using these computings are population size of the cell inside a human body, lifetime of a cell, mutation, what exactly the mutation, and if the specific mutation happens, or specific things are issue in the human cell, how much it will grow. So population of the cell is also calculated in the environment, or inside the tissue or inside the body. Moving ahead, one more application for this numerical methods is financial industry. You can see the modern business make use of numerical techniques to allocate the resource effectively. You know that each in financial industry, you know that uh, each and every second, or each and every investment will bring 10x or 12x or 100x growth to to the business. Once you maintain your financial where to put your money on, and how to do business, these are all the problems which is to be formulated by using equations, and then they are trying to solve it by using numerical methods. So what are all the problems which is addressed in financial industry are manufacturing, storage, scheduling, investments, and others. Quantitative analysts have expertise in this area, use algorithms, several algorithms which is tailor made to the financial industry are available on maintaining the risk and interest calculations. Or you see several stock markets are also dependent on these numerical solutions to come up with these problems to solve whether your investment should not go uh, bankrupt, or it should be much more fruitful, it should give much more gain or profit to the business or an individual. And you see a lot of mobile Android or based applications which are all coming out right now, which is showing the if you invest in this stock, how much growth it will give, or previous 5 years how much growth it gives. So there are all people used to use numerical methods. Not only that, there are a lot of job opportunities for the people who can able to understand these problems and solve it, or come up with the uh, conversion of this problem into a computational methods to solve those problems. And this is one of the interesting book which has wrote in financial mathematics series of numerical method for finance, where there are a lot of methods. If any of the students are much more interested in numerical methods, and not to be like, there are a lot of openings in this field as well for the students who had an expertise in this. And one more on spacecraft dynamics. I still remember sometimes APJ Abdul Kalam also used to say there are several parameters which is handled, or which is taken care by using computers to while launching of the spacecraft, and how it exactly. And again, there are a lot of mathematical modeling, and as well as solving those solutions and trying to see the aerofoil approach of it, to see in the launch of each each spacecraft. And you know that those are all a separate field of study, and separate field of stress to understand and to gauge where exactly there exists a lot of stress in which part of the spacecraft while uh, launching those elements into the space. And there are some of these problems are solvable by using computers along with numerical methods. Moving ahead, as my talk is much more getting towards converging on machine learning and artificial intelligence method, I will give a little bit intro on machine learning, what exactly it is, why people are much more crazed on computer industry, and not only in computer industry, all part of the engineering. People want to use these machine learning problems or artificial intelligence. A computer can solve its own problem. It cannot, but we should give a computer consumable thing, but in a less way, but it will automatically figure out, and it solve the problem just like human. That's what the idea behind this artificial intelligence. So artificial intelligence is another field where machine learning is applied to help numerical analysis, which is applied to day-to-day world. You can see what are all kind of problems in machine learning people are coming across. Data mining, automatedly it should go through hundreds of books, hundreds of materials to collect and understand and to solve the problems out of it. Assume that how how exactly Google search works, how exactly it, it gets lucky to you to get the word what you are searching, and it is showing accurate solution to your search you might have come across. And you know what are all machine learning techniques and artificial intelligence technique Google use, and they have some dedicated softwares. They have dedicated hardwares, for instance, like TPU, tensor processing unit, which is much more advanced than GPU, graphical processing unit, which is exactly tailor made to do those analysis. Google have their own TPUs to be used to solve those problems. And how much it is useful, a layman, a layman who doesn't even study even plus two can able to interact with the Google and trying to understand if he doesn't know anything. Sometimes even people used to search anything on the earth. Uh, I still remember long back when I was a child, people used to say that if you can you search anything on this on the Google, whether it gives any result on this. So we used to search 10 paise on Google. Even those time that money was not running, there exists an exact material of it, and what is the metal it is used to make that 10 paise coin. So so these are all, before a decade it is giving a solution, but now it is much more advanced, and a lot of computational techniques are also helping it, and supercomputing computers are also helping you come up those problems. And what are all the algorithms, classification problems it automatically do, learning the problems, learning and giving the solution to the problems, numerical neural network based learning. It learns. It is an advanced technique of artificial intelligence, which I will give you some intro to you in further slides. Deep learning, or artificial intelligence robot, or artificial intelligence based you can see, you can hear, or you can see in your newspapers, people are talking about, or Amazon is talking about mm, drone based delivery system, or automated inventory management. What is the product, it will go and it will fetch the product and it will dispatch the product. So these are all automated techniques for you as a budding students. You will see in your later life, all those things which you have seen in Hollywood movies will be become a reality, and it is much accurate, and it will be helping you out in your day-to-day life in your future, which will be mostly based on this machine learning techniques. Now the question is how exactly these numerical techniques and numerical problems are solving the solution to those problems. Once you come up with those scenarios, or ML models, or artificial intelligence models, I will be discussing on. I'm giving a pass right here. If anyone is having any questions, you can post it, or if you're just keeping mum, I will be continuing my talk. Cool. If you find it shy to ask a question, you can
Sir,
also.
sir, you can go ahead. I have unmuted.
Okay.
Hello, sir. Can you hear me?
Sorry.
Hello, sir. Can you hear me?
Yeah, I can hear you.
Yeah. Actually, I have one question. So right now, you are progressing from numerical methods to me. So right now, we are recently seeing papers on how deep learning method is approached to solve partial differential equations.
Okay.
So I cannot say whether they are replacing numerical methods or not, but there is no study between the numerical methods and deep learning approaches. So, can you see any, is there any possibility of having such a kind of result in future? And also one more thing, in the deep learning approaches, they basically studied on how error is reducing, and that is not the order of convergences or something like that, which is very crucial in numerical method, conventional numerical method.
Okay.
So do you think there is a possibility of studying order of convergences even when you try to use the deep learning approaches?
Quite interesting question from you. In the sense, like once you go further in your research or usability, if sometimes like numerical methods are interchangingly called as it can able to solve the problems, but sometimes probabilistic and statistical problems also merge along with numerical methods to solve the problems. So the exact uh, thing is, you cannot uh, classify numerical methods separately to the neural network problem. I will give the reason for it. In next slide, I will be walking you through um, how in normal equations are probabilistic machine learning equations and numerical equations is converted uh, into the numerical method problem, and how exactly they are solving it. I will show with some of the examples, and there is no doubt that regression or logistic regressions or curve fitting are not numerical method. You cannot deny it. But I will be showing you that those those regression or linear regressions or non-linear curve fittings are exactly used in machine learning problem. How and that will give a little bit more idea to it. And from uh, the logistic problems and logistic regression problems, how exactly numerical problem is built, I will try to give those I will try to fill those gaps, which mostly, because I am from mathematical background, I can able to show you, but mostly it is a black box to the general people. But for sure I will show that. And with this, if you have some question, feel free to also put it in the chat if you feel shy, but your questions are interesting. In the interest of time, I can move ahead, and I will take at last your or after all this presentation, I will take your questions. Moving ahead.
Sir, I have a follow-up question. Shall I ask you at the end?
Sorry.
I have a follow-up question on this. Shall I ask it at the end or
Yeah, you can
just to
ask it at end, because I mean by that is, I will give you the exact essence of it. Then
okay,
you may have much more questions, I feel. Interesting.
okay.
Okay, but before going to that machine learning ML problems and artificial intelligence problem, you should be having your the computational skills, because unless you convert your mathematical problems uh, into the computer oriented problems, you cannot solve the problems. And these are all some of the softwares or applications which is helpful to solve those problems. For instance, MATLAB. Some of these data analysis peoples or machine learning expert or artificial intelligence experts are using MATLAB and Python, which is most widely used. But Fortran is almost obsolete right now, but still some of the research scientists are still using it. I have seen in several research labs still they are using it. And software programs to minimize the error, so how much iterations it can do in computer, so much high performance and supercomputers are needed. You might hear some of the big research labs are having dedicated computers, dedicated GPUs, or a huge high core computers, like 30 core or up to 250 core computer, which is available in IISc Research Lab India, in Bangalore, which is the biggest computer as of now in India. Moving ahead, I will be talking about linear regression. One of the most widely used machine learning model for regression is known as linear regression, which is nothing but a linear curve fitting. Or, for instance, you can see here there exist several points, and if we want to know how exactly this data is putting, or this data is in the field of with respect to independent and dependent variable, a linear line or y is equal to ax plus b is drawn across this data, which resembles the line of regression, and these are all the data points. And how exactly it is written in uh, in linear function way, y of x equal to w power t of x plus error e. You know that we are converting this into we are converting it into matrix form, w power t of x, and uh, represent it in inner or scalar products between input vector and the model weights. So we call it the coefficient of x as a weight of it. And you know that whenever we are talking about solving it by using uh, the numerical methods, it will be having some error, and we will be separately calculating the residual error between our linear predictions and the exact true value or ground truth. That's what we used to call. And epsilon has a Gaussian normal, and you know what exactly the normal curve, and uh, Gaussian normal should be exactly a bell curve, where mu is the mean and sigma square is the variance. Now, the connection between linear regression and Gaussians are more explicit. For instance, we will convert this problem into probability of y given x comma t as a parameter will be converted into the normal or normal distribution of y such that mu of x comma sigma square, which is nothing but, instead of taking the probability of the previous dot of the data, probability of the previous data, such that it will be converted into numerical equations or numerical curve with conditional statement of mu of x comma sigma square of x. You can see this probability is converted into a numerical Gaussian curve. This makes it clear that the model is a conditional probability density function. For example, suppose if we are having only one dimensional input, we can represent this response into w naught plus w1x, and w naught is an intercept and w1 is the slope of coefficient. And linear regression can be made to model non-linear relationship by replacing x with some non-linear equations. This is nothing but uh, if your data is very curvy and your data points, you cannot uh, take it in a straight line, you cannot fit it in a straight line just like this data points, then you have to introduce a non-linear curve of order x square. For instance, a naught plus a1 x plus a2 x square. So you are increasing the complexity, or you are introducing a non-linear x into x to try to fit this data. So that's what it exactly happens in machine learning problem. So if you introduce, this is the data point and you want to see what is the line of the curve up to the degree of 14, then this is the line you will get by converting it into a normal curve by using the degree of 14. Now the machine learning is the model. Machine learning model will try to understand or try to fit your curve based on the data by using how many number of orders. That's the again a question. You cannot be overfitting it, which is called, if it is an overfitting problem, or how much degree or how much overfitting it takes, so much of computational power or so much of computational softwares are needed. So very less degree you can solve by hand itself. For instance, a linear equation with 1 degree you can solve by using your hand itself, not even need for a computer. Once if it is higher degree, then it needs a computer, but you cannot afford to have higher degree more than 10 or 20. So it should be less degree, it should be, that is the trade-off, and your curve fitting should be much more accurate. So for the same point, you can see at degree 20 it tried to fit each point in more than 20 degree, but this looks like very overfitting, means your curve is going each line to fit it. So this is again a polynomial regression problem which is illustrated right here. Now the question is how you convert the exact your input data or training data. From the training data you come up with a curve, and if a new dot, if you want to predict for a new dot where exactly it will be plotted, or at 30 value where exactly this line will go. That's what the answer we will be trying to solve by using this regression problem. And to solve this regression problem, we will be converting the probabilistic problem into a Gaussian problem and solving it. That's what exactly a machine learning does. It will try to understand the training data or dotted line and predict for the new data. Moving ahead, one more example on logistic regression. Okay, we replace Gaussian distribution for Y with Bernoulli distribution. What is exactly Bernoulli distribution? Yes or no case are mostly dealt by Bernoulli equation, and your probabilistic problem will be converted into a Bernoulli equation, not a normal distribution, just like previously. And how exactly it is done? You know that the response is a binary. Y is 0 1, success or failure, true false. So all those output you want to you have a mathematics score of a students of all the class, but you want to see how many people have passed and how many people are failed. So you put a cutoff of 30, or you put a cutoff of 50 score, or you put a cutoff of 75. Who are all the students are getting more than 75, he will be termed as pass, and those who is below that, it will be fail. And how that the exact classification of binary classification, yes or no, pass or fail, so it is done by using the logistic regression. So if there exist several points in this space, and you want to cluster or you want to bucket them into two different bucket, yes or no or pass or fail, you will be using the logistic regression. And the logistic regression is again written in the probabilistic formula or conditional probability formula of Y, because Y we previously know it, and you want to find X with the parameter W, and by this probability is converted into Bernoulli equation. Again from Y it will be get trained for the data previously, which are all pass, which are all fail, and what is the cutoff, it will learn from the training data, and it will go and predict on the test data. So we compute a linear combination of inputs, which is it from the training data, and by using sigmoid functions, and we will try to find what is the threshold or what is the cutoff by using the equations, sigmoid functions. Here you can see the example. Now the example given in this curve is the sigmoid function or logistic function is given as sine my minus infinity to 0, and if sine is 0 value, then it will give 0.5 value, and sine is infinity, it will give 1 value. So 0.5, which are all lesser than 0.5 and greater than 0.5, will be in two different buckets, and it will solve your problems. And we notice that this decision rule has a non-zero error rate even on training set. This is because the data is not linearly separable. There exists some of the data points. You can see that there exists this data, and this data, and you say that this is the cutoff, and which are all uh, left to it will go to one bucket, and which are all right to it will go to one bucket. But where this data will fall, so it cannot be linearly separable. So there exists some of the problems in which the data is not linearly separable. uh, let me go to the feed forward loop, which is the base for the deep learning and which is the base for artificial intelligence. There are multi-layer perceptron which learns from the training data and it will predict on the new data. So I'm giving one example of feed forward neural network, again in the sense of uh, normal curve, but the normal curve is having some non-linear term z of x, which is nothing but it is given right here, and it is a separate activation. G is nothing but non-linear activation function. Okay, what, what is a gap between this and logistic regression? It is logistic regression is very simple. You just put into separate cluster. So the multi-layer perceptron is a series of logistic regression stacked on top of each other. There are a kind of several logistic regression will build a machine learning problem. The two, if it is a non-linear learning the parameters, for instance the coefficient values it is getting learned. So how it is exactly, for sure it is very complicated to understand, but I'm not stressing you to learn all those mathematics behind it, but at least you have to understand there exists certain mathematical formula which is stacked together, which are all solving you the problem, the which are all learning some of the characteristics of the training set, and it is predicting in the test set. So which is in itself giving this problem, which in itself learning it and predicting it. That's learning capability which we are giving it. That's the exact thing which is called artificial intelligence, which is given to the computer. You give a bunch of data which is right and bunch of data which is wrong, and if you give a new data it should predict it. If you have a huge patient sample in which a doctor had classified that which is a cancerous scan and which is not a cancerous scan, which is cancerous MRI and which is not cancerous MRI, and if those data is given to the computer to train it to predict for a new patient, if it comes, whether this scan shows that he is having cancer or not, but those interpretation and those conversion is having lot of numerical solutions which is solved by using this kind of convergence problems. Or this is the base for deep learning, multi-layer perceptron, which I am talking about. Sorry to skip the one other thing, because this is the continuity of logistic function to multi-layer perceptron to the deep learning to the artificial intelligence. And to complete all of it, I will also discuss one other problem of random forest, which is taking a decision tree approach, which is in itself a little bit different approach, but it is an interesting approach again. It will try to divide it the same problem into several decision tree, and it will take and vote among themselves to come up with the decision tree. It can also be again put put into the probability of C such that we had already happened by using again the summation of the problem, which looked like similar to the numerical method. Where we will cut into several pieces and try to solve approximate solution of the problems and multiple root of it, and we will find a solution to the problem. Now this is my final slide, which talks about both machine learning approach and artificial intelligence to it. So I'm thankful for your keen listening, and I will also try to answer some of the problems or some of your understanding on data science, or if you want to know what in real world problems in industry, how they formulate into mathematical equations and how it is converted into a computer problem and how it is solved. I will be happy to answer some of the problems, or if you have a general problem or general understanding of tips and tricks to get into the industry or to get a job in industry, or a kind of industry which is related to data science, artificial intelligence and machine learning, or some of the courses in and around of it, you can put your questions also in the chat box, or even you can ask me to answer it. So I'm with this I'm stopping my I'm just halting my talk right here. I will put you some of the I will take some of the questions from here.
Please raise your hand to ask the questions.